Thank you for joining this lesson. We are going to study some physics. So we will consider a topic called fluid flow, which is a Form 2 topic. And we look at volume flux, the mass flux, and equation of continuity. Therefore, what we call volume flux is the volume of a fluid that flows at a given section per unit time. Therefore, we can consider a tube of flow whereby it has a section here. So we can call this section here, we can call this one section A, which is having, of course, some area. Then on the other side, we have a section B, another section B. At B, we also have another area 2. Therefore, because we are told that volume flux is the volume of a fluid that flows at a given section per unit time, then we can say the volume at A is going to be, we usually multiply cross-section area times this length for us to get the volume at that section. So we will have cross-section area times the distance there, the distance at A. So this one gives us the volume at A. So what we are calling volume flux is the volume per unit time. Volume out of time. And unit time is in seconds. Therefore, we will talk of the volume, which is already defined here, divided by time. It is very definite to know that distance out of time gives us velocity. Therefore, distance out of time gives velocity. Therefore, this can lead us to concluding that since the time is 1 second, we are talking of per unit time, then distance divided by time, which is 1 second, will become velocity, and the value of the velocity will be equal to the distance at A. Therefore, instead of distance at A, we can just use the velocity at A, since distance out of time gives us velocity, and the velocity is just 1 unit. Therefore, in this case, we can say volume flux at A, is going to be the cross-section area at A times the distance at A, because we've divided with the time, which is just 1. And this is equal to area at A times the velocity at A. So we can just call it velocity 1, the velocity at A. So this means that now at B, we shall just have the same copied on the other side. Volume flux at point B, we will have the cross-section area there at B times the velocity at B, or we just give them 1 instead of 1 and 1. For B, we use area at B, we call it area 2, and velocity at B, velocity 2. Therefore, that is what we call volume flux. There is another term here, which we are calling a mass flux. And mass flux is the mass of a fluid. The mass of a fluid passing through a given section passing through a given session per unit time. Per unit time. Therefore, because we've already described what volume flux is, we can say because density equals to mass out of volume, then volume or mass is equal to density times volume. If mass equals to density times volume, this is by definition, then it means mass flux is equal to density multiplied by volume flux. And using initials, we can say volume flux, which is area times velocity, then will be multiplied by density to give us mass flux. We said for a fluid to have a streamline flow, it has to be, the flow has to be streamline. Therefore, we say that since the fluid is having a streamline flow, the mass flux is uniform, or rather, mass flux at A is going to be the mass flux at B. So mass flux at A is going to be the same as the mass flux at B. And remember, mass flux is volume flux times density. Therefore, volume flux at A, which is volume flux multiplied by the density of this liquid, is going to be area at B, the velocity at B, times density. Remember, the fluid which is passing at A is the one which is going to pass at point B. Therefore, the density is just of the same fluid. And having this one related, we can have the densities cancelling, and we will have area 1 times velocity 1 equals to area 2 times velocity 2. This one is called the equation of continuity. The equation of continuity. So this is what will be applied continuity. This is what will be applied in calculations, the equation of continuity. So make sure you keep connected. Examples will be coming in the next video. Thank you for following. Subscribe and share.